Hey, how are you all? Happy belated Christmas and happy advanced New Year, I would say. And you know what? If I were sent, I would say, ho, welcome to the session of Concept Capsules, alright? We are doing this, and in the last session, we already discussed something, right? Hey Ananya, hello Chavi, hey Utkarsh. Yes, AEK Learning. Hey people, are you ready? First of all, the drill you know. Am I clearly audible and visible to you first of all? Tell me this. Hello Soumya. Yes guys. Clearly audible and visible. I think I am. But I just want to confirm this. Come on. I hope you enjoyed your holidays. Christmas. Nice. Thanks Ananya. Alright. Okay. I've got a thumbs up also from Sai. Alright. Hey Niju. Aryan is asking, is Ment there today? See, I know what you're asking. You are asking, is Menti there today? It's okay, I understood that. So yes, Menti is there. I know you all love Menti. You all love those quiz. You all love the leaderboard. Yes, it will be there. Today, first of all, we'll deal with the concepts and then we'll go to Menti. And it's a little different. Don't worry. I'll tell you in the end what exactly is different. Is not very much different. Pranam, sir. Pranam. Yes. Oh, you don't love Menti, huh? Why? It's alright, Samved. I have questions for you during the session also. So during the session also we have one or two very good questions. Yes, Nisha, definitely. Sure, Vivek. Ask whatever doubt you have. Good evening, Ritika. Good evening, Rids. So guys, I hope all of us are here. If your friends are not there, please call them. And you get the notification, right? You have subscribed. I'm assuming this. All right. Okay. So let's start. Let's start with combination of resistors, session 2 of our concept capsule series. And you know what we are doing? This is for term 2, right? Sorry. Point 1. Oh, Mukesh. No, so it's okay, Mukesh, don't worry. You won't miss anything. It's fine. Thanks, Ambit. Alright, guys. Come on, let's start. Let's get serious. Combination of resistors, we have discussed the basics of electricity, right? We have discussed Ohm's law, voltage, current, resistance, the basic of resistance, conductors, insulators, everything fine, right? So today, we'll move forward. Today, we'll do combination of resistances, the actual thing which is required in this chapter, right? From today quiz time series. Yes, Fennel, you're right. So I think you got the idea, half of it at least. Chemistry, Andy, what are you asking? Yeah, series and parallel connection. All right, guys, come on, let's start. And first of all, I just want to ask something from you. It's a hypothetical scenario, but still watch. All right, so come on, focus, attentive and interactive. That's what I want. Come on, I'll tell you a case, a story, you can say, a hypothetical case, but whatever. There was one time someone called an electrician. Electrician was amateur. He came to the house. They asked, come on, do the wiring for this house. All right, they did the wiring. Then what happened was, the owner, he turned the switch on, nothing happened. He turned another switch on, nothing happened. Slowly he turned all the switches on, and you know what he observed? He observed things started working, like fan started moving over here, the television started, and there's mixer also, there is this stereo system also. Everything started little slow, little dim, but still it was working. So don't worry, we'll deal with this. I'll tell you, don't worry. Come on. This scenario first. Did you understand the case? All right. Now, owner is confused. What exactly happened? Now, you, being a student of science, can you think of a possible solution? What went wrong? All right. No, puppy, you're not late as such. I just told a hypothetical scenario where there is a house in which an electrician was called to do the wiring of the house. He did something, then owner turned all the switches on until nothing started. But when he turned the last switch on, everything started and it was dim. All right. So This is my case to you. And I want you to think of the answer. What could have gone wrong? Okay, Aryan is saying low voltage. Okay, Fenner is saying they are connected in series. Alright, SNES, series. Nice. I really wish you guys become engineers. I mean, you'll be great engineers. Yes, okay, Utkarsh is saying it's a series combination. Alright. Which means, let's discuss towards these things, right? Let's discuss series in parallel. Alright. Let's start with, first of all, series combination. I'm not telling what's the reason. I mean, you have figured out it. You have figured it out. At least you have figured 70-80%. I mean, what exactly went wrong? I'll tell you till the end. Don't worry. But you have got the good amount of answers for this. Yes. All right, guys. Come on. Series. Let's start with series combination of resistors. What is it? I mean, you know, these are 3 resistors. If you connect them end to end, what you will get? You will get a series combination of resistors. True. Yes. Ammeter and galvanometer. Sai, don't worry. See, right now if I take this question now, the problem will digress from the topic. But I'll make sure I'll answer this. Don't worry. Alright. By the end, since we are going to reach the end now, around 5:25, just ask this question again from me. Fine? And don't worry, I promise. We'll deal with this. Yes, AEK learning. Nice. Yes. Priya is answering Sai, your question. I mean, kind of. All right. Pavan is also answering. So I think a lot of people are helping me out over here. Come on, guys. Let's focus. Let's deal with this combination thing first, and then we'll deal with this question also. Ammeter versus galvanometer. Don't worry. So, series combination. I hope you are noting it down first of all. Series combination. 2 or more resistances are connected in end to end, right? The connection is from end to end. You can see end of one resistance is connected to the beginning of the next resistance. This is a series combination. You're right. Yes. Voltage different across different resistances. All right. Nice. Good lot over here. I'm really happy with this. So there is one analogy which is very famous while we are dealing with circuits, right? When you're talking about series, we think it is like water flowing in a pipe. So here, what do you see? You see electrons, right? Assume it to be like water or electrons flowing in a pipe, and resistance is what? It's like a constraint. It's like a bottleneck, right? So first resistance, let's say this is R1. It is one bottleneck. Yes. Next, if let's say there is one more resistance, there is another bottleneck. It is another constraint in the flow of the water or electrons in this case, right? Correct. Fine. This is an analogy we are talking about, right? Yes. Is a combination of resistors. Nice. Yes. Okay. So what happens then? The analogy works. I mean, in water, if you talk about Bernoulli's equation, everything, pressure drop is going to happen. Here, voltage drop is going to happen, right? So electrons have a single path to complete the circuit. I mean, they don't have anywhere else to go. It's just one path. Maybe there are resistances, maybe there are obstructions, maybe there are constraints, but it's one path only, right? So you can assume electrons have a single path to complete the circuit. The effective resistance of the circuit increases in series arrangement. You know this. Nice. I can see good answers are coming up. Nice. The same. So I think that's why last component start, but very dim. Nice here. Good. Very good. Okay. Hello, Legend Noob. Oh, nice name. All right. So what is happening? When you add one more resistance, what I'm doing, I'm adding one more bulb. What is bulb? Bulb is nothing but it's a resistance for you. For you, nothing matters. Maybe it's a fan. Maybe it's any electrical equipment which is drawing current. It's a resistance for you till now. All right. So when you put one more resistance, what happens? You see, flow of electrons, it is reduced, right? The amount of flow of electrons, which means what? Current is getting reduced. What was current? Come on. What was current? We had this definition in the first session. Come on. Current was? What do I mean by second statement? Second statement, see, I told you 2 statements. First of all, resistance is like a constraint in that pipe, right? So when it has nowhere else to go, it can only flow in that pipe. I mean, it can't take sideways or any other path. That's why. It is only one path, and when you add one more resistance, what happens? That flow decreases, means current decreases, right? Yes, flow of charges. Very good. Flow of electrons, yes, or charges. Very good. Rate of flow of charge is nothing but current. Time is very important, you know. When you only say flow of charges, it is not a complete definition. Rate of flow. Time is a crucial part over there. How much charge has flown in how much time? That is current, right? Yes. You will get weekly schedule creation. Don't worry. I mean, it's there on the channel, no? I mean, if it's not there, it'll come. Don't worry. It's a matter of time. Yes, Pabia, we have. I mean, we have a little differently, but yes, we have. Yes, rate of flow of electrons. Disha, you are right. That's the important thing. Rate. All right. Fine. Series combination of resistors. All right. So, what did we understand? Current remains same, right? Current remains same throughout the circuit. Why? Because it's just one wire. Current can't take any other path. That's why. Hello, Chitra. Yes, yes, Priya, you are right over there. Okay. So, first very important thing about series is current flowing remains same. Fine. Okay. All right. Then what do we see? I mean, all these answers I have seen in the chat. You guys have already answered. I'm just reiterating them. Thank you, Sai. All right. So, I equals Q by T. You're right over there. Yes, current is same, but voltage is different. That is what? That is a voltage drop on each resistor, right? Voltage drop or potential difference across each resistor is different. When I say potential difference across each resistor, what we are doing? I mean, let's say we are taking a voltmeter, connecting it, measuring it one time, then we take the same voltmeter, measure it for here then, and we are saying it is different for all the resistors. All right. Yes, Pabi, I have answered this question. Huh? We have. Yes, in series AEK learning, current remains same in series, right? Yes. In the chat, guys, you have your answers. Menti at 5:30. All right. Fine. So, we've got the basics right. Current is same, fine. Potential drop is different at all the resistors. Okay. So let's start with some mathematic derivations, right? Let's start with some derivations. And what are we trying to derive? We are trying to derive that formula that R equals R1 plus R2 plus R3, right? That's also important. Okay. All right. Fine. All right. Come on. Let's do this. And I'm sure you know how to do it. Just cross-check with me. Do it on your notebook, right? And just cross-check with me. First of all, what is happening? I'm saying this total voltage of this battery is getting dropped on the different resistors. Fine. So I have said V1 is the drop on the first, V2 on the second, and V3 on the third one, right? V3 on the third one. Fine. We are saying V equals V1 plus V2 plus V3. All right. All right. So V equals IR. We have learned this Ohm's law, right? Kind of, Mukesh, you can say. I mean, every time there is a constraint, right? This is a constraint. So whatever is the narrowest constraint, it is basically telling you that overall this much constraint has happened, and that's why the total flow has decreased that much. So you can say that. In a way, it is correct. Voltage is, see, whenever we say common language, we say voltage, now it means potential difference, all right? Volts, Papia. I mean, it's a common way of telling. I mean, you know, when you go into the market to buy a cell, let's say, you ask, sir, kitna voltage hai? Sir, mere ko 5 volt ka de do, right? 9 volt ka de do, 12 volt ka de do. That is one way of telling it. That's a common language. Fine. So, V equals IR. How? Ohm's law. We know this. Okay. So, if I just simplify the circuit like this, only one resistance, let's say this is R equivalent. Fine. Right? Right? Okay. Nice. How can we say? How can we say? When we say this now, here at this point the voltage is V, and at this point the voltage is 0. You can take it as voltage is like a measure of energy. Here on this side, on the side of higher potential, you start with highest energy. Then as you cross 1, 2, 3 barriers or constraints, your energy decreases. And here you can say it is 0, right? In a way of understanding. All right. So which means this whole V dropped on V1, V2 and V3, right? Fine. Okay. Yes. Yes. Easy peasy topic. You're right over there, Ishast. Fine. Okay. Now, come on. I can say V is, this is IR equivalent is equal to IR1. Voltage drop on each resistor. IR1 plus IR2 plus IR3. That's fine. Now current is same, which means I can cancel it out on both the sides. It comes out to be R equivalent equals R1 plus R2 plus R3. Fine. What we take away from this whole derivation is equivalent resistance is more, right? In the case of series combination. Fine. It is more than individual resistances, right? Yes. Okay. IR equals, yes, Priya, you are right. Very good. Nice. Okay. So, if you have n number of resistance as a combination in series, what are you doing? You are adding R plus R plus R plus R. How many times? N times. What will you say? The total resistance becomes, it becomes NR, right? It becomes NR. All right. Nice, Pinal. It's a well elaborated answer. Yes, I gets cancelled. You're right. Yes, you're right. Yasharth. My bad. Yes, N times R, Papiya. You're right. Net resistance. Cool. All right. It means we are on right track. Let's move then. Let's move to questions. I mean, once you have got the concept right, what is left to apply to questions? Let's try. Come on. So it's an easy question. I'm assuming you'll just give me answers like this without even picking your pen. Come on. How many 12 ohm resistors are needed to be connected in a series circuit to provide an equivalent resistance of 60 ohms? All right. You have 12 ohm resistors, as many as you want. What do you want? What is your need? Nice. Your need is to get an equivalent resistance of 60 ohm, and you have to connect them in series, which means you can do, come on, this thing, N times R. 60 ohms equals N times R is 12 ohms. So what do you get? 5 equals N. Right? 12 5 is 60. Nice, Shraddha. Nice. All right. So I understand it was a very easy question. And you guys are better than this. You need more. So let me just cover everything. I'll give you a good question. All right, come on. Nice, Disha. Very good. Anusuya. Everybody has got the correct answer. Akshit, it's okay, Akshit. Don't worry. Till now we have just covered the basics. Basics of series resistance. That has happened. Yes. इतना ही हुआ है अभी. ठीक है. Let's move forward to parallel combination resistors. Parallel. So parallel, when you talk about parallel lines, what do we assume? We assume them to be, these two lines are parallel, these three lines are parallel. So I can connect these resistances in parallel. So this is how this language, this word is helping you out, right? Okay. Yes, parallel, fine. R1, R2, R3. What is the key word? The key thing is the terminals of the resistors are connected between the same two nodes. Now don't be confused. If today you are seeing these three resistors like this, tomorrow they might come like this. Fine. Or if the examiner wants to confuse you, he can always do this. Connect these three, right? And then do cross connections. But what you need to do is, you always need to check if there is a common node for all the three resistors, right? This is that common node, this is that common node, and all the three resistors are connected to these common nodes, right? Yes, Aishka, you're right. Non-intersecting lines are parallel, right? You're right, Deepak. Yes. Opposite sides, yes, Erika Learning, you're right. Opposite sides of the resistors, right? Two ends of the resistors, they should have common nodes. Fine. Okay. Now, if we talk about analogy again, so why are we talking about analogy again and again? It helps to understand, right? The way I understood it, see, if this is like the motion of electrons in a wire or flow of water in a pipe, going forward, it has three ways, right? It has three ways. Now, what is resistance? Resistance is like a constraint, like a bottleneck, right? So if this is a smaller bottleneck, this is a slightly bigger bottleneck, and this is the biggest bottleneck, means it is, this one is constricting more, this is the second one, and this is the third one. Now tell me, from which resistance will current flow more? Come on. No, Arjun. In these three, resistance is different ना. यहाँ opening छोटा है ना? यहाँ पर opening उससे बड़ा है और यहाँ पर opening सबसे बड़ा है. इसका मतलब flow of पानी ले लो, or you take electrons. You either take flow of electrons or you take flow of water. Think from which constraint will more electrons or more water can flow? Yes, number 3. इसका मतलब this is a way to understand that in parallel combination, wherever you have more resistance, current will flow less, and that's how the current will be divided. ठीक है? Got this figured out? Yes, third one will be high current. You are right. Very good, guys. So the electrons have multiple paths to complete the circuit. That is one thing. All right. Next is the effective resistance of circuit decreases in parallel arrangement. Yes, we know this. Why? Why? Come on. The formula is something which I assume you know. If this is the case and I add more resistance in parallel, you will see that more current is flowing, right? Fine. Okay. This is all a qualitative understanding of the parallel arrangement of resistances, right? Let's go mathematics. Let's talk derivations, right? Come on. Potential difference across resistors is the same. Why, sir? Come on. This is one node and all the nodes have common points, which means if this is V, it is going to be V, right? All the three resistors will get equal potential difference. Yes, resistance is nice, Yashas. Very good. Phenyl, oh, nice. Okay. Nice. I'm getting good answers over here. All right, come on. Let's derive. And how did you derive? The basic thing that you started from is, come on, can someone tell me? See, I understand, Kartike, Yasharth, you are giving correct answers. Can someone tell me how you start this derivation? I mean, what is the basic thing? Final formula is fine. We have to remember that. What is the basic thing? The basic is, come on. Yes, Disha. Very good. Current. You start from current. In the series case, what was getting distributed? Voltage was distributing. That's why we said that V equals V1 plus V2 plus V3 in the series case, right? Here, voltage is same. What is getting distributed? Current is getting distributed. This is the total current I. It will get divided into three parts, I1, I2, I3, and then recombine, right? I1, I, this is, and it will recombine and form I again. Sukhjot, you are getting late. I think you got late a little bit. It's okay. Parallel combinations only we have discussed till now. Yes? Okay. Yes, Kartike, you are right. Very good. V equals IR and I equals V by R. Very good. AEK learning. Nice. So, we start from the division of current. I equals I1 plus I2 plus I3. And we have our very own Ohm's law. Very familiar. I equals V by R. So, I can say, if this circuit was broken into a simplified circuit like this, and this was the R equivalent, and I would have said this is I. So my total voltage drop, that is this, right? The total current, I would say, I would be V upon R equivalent. It would be equal to V is here. Here also it is V, and here also it is V. So current would be V upon R1, right? This is I1. I2 is V upon R2, and I3 is V upon R3. Yes, and V will get cancelled. Divneet, you are right. Yes, Sukhjot, it is. Okay. Firewolf, what is this? Okay, Niranjan, don't worry. You haven't missed a lot of things, but yeah, you are a little late. It's okay. Don't worry, Rohit, it's coming, it's coming. So the quickly you finish this, the quickly will come to Menti. Come on. Let's do it. This is the equivalent formula you have got. And why V is same? Yeah. Nodes is same, right? I mean, these nodes are same, and that's why it will get same potential. What will happen? Current will get divided, right? Different paths are going. You are going like this, and you have got three paths in front of you. You have divide. The current has to divide, right? So that's why. Cool. What is the ultimate takeaway from this? First of all, the ultimate takeaway is equivalent resistance in parallel is less than individual resistances, and this is very important. Why? Because we'll use it. Don't worry. There's a question coming for you. R, and all these. If you have n number of resistances in parallel, what you will do, you will say R equivalent equals R by N. Fine. Come on guys, this is the question. It's a good question. Come on, give me correct answer very quickly and we'll switch to Menti. Come on. In the given circuit, each resistor is of resistances 2 ohm. Alright, fine. The equivalent resistance of circuit you have to find, and you find the current supplied by the battery. The total current supplied by the battery. Fine. Okay. Shraddha, when I say nodes, na, think of, you have one resistance, you have let's say one more resistance, right? If these two are connected with common point, I would say their end points are connected to one node. That is what I'm saying, node, right? What could have been different? Difference could have been if it was connected like this. Now it is a series connection, right? Yes, yes, come on. Alright, Yashad is saying 9 ohms. Fine. So I'll just simplify the circuit for you a little bit. I'll just show you 2 ohms is the thing which is given to us in the question. Fine. Okay. Alright. Come on guys, come on. Quickly. Firewolf girl, 9, 9, 5, 8. You have got a variety over here. Okay, she's saying 5. Alright. Alright. Guys, you know, the question is not difficult. It's just one very small point. If you miss that point, you go wrong in the question. If you catch that point, this question cannot be made wrong, however hard you try it. So what is that point? And let me give you a hint. It is regarding this one. Come on. See, I have given you enough hints now. Yes, reciprocal of series of combination. Yes, Priya, you are right. Come on. Okay. See, when we were talking about nodes, na, think. Resistance is like a constraint. Current likes to flow from the path of least resistance. If I have like this, tell me, if there is current flowing, will current flow from the resistance or it won't flow from the resistance? This is my main question, guys. Come on. It won't. There is obstruction in resistance. It will choose a path where there is no resistance. So that's why, you know what? This 2 ohm, it doesn't even exist. Why? Because this is a path which is very clearly shorted. It's a path of zero resistance. So current will flow that path, right? So what is happening? It is shorted, which means it does not exist. So what is the next thing? It is equivalent to, you will remove it. This is 2, this is 1, this is 2. Now it's series combination 2 plus 1 plus 2. What is this? 5. You will get 5 ohm as the equivalent resistance and you can find the current. All the people, you got 5, very good. If you made a mistake, very, very good, because now you won't repeat it again. Alright, so we got this, fine. Ohm's law, V equals IR, and you will get 5.15, that is 1 ampere. Fine. Now, that is okay. Why third one? Alright. Why third not came? See, Ayan, again I'm explaining. If you have a circuit like this, right? If this is the battery, I understand current will flow. But if you connect a wire like this, current will flow with a path of least resistance. It means this is not in picture now. For you, this circuit is like this. It's a short circuit. That's why the 2 ohm was removed. Fine. It's okay, Papia. Don't worry. Nice. 1 ampere. Can you tell me first one or second one? Which one is series or which one is parallel? How 1 ohm? Disha, I think I just answered, na? Come on. Alright. The first one is series. Figure 1 is going to be series combination. R1, R2 and R3. Why? This is like potential difference, the height difference, and this is the water flowing. Same current is there. If you have this analogy, second one is parallel, right? Fine. Okay. Now, with this said, you will understand. You have understood the analogy also. You have understood a lot of things today. Which means, and you gave me the answer. Yes. You gave me the answer. What was the problem? The problem was Yes, the amateur electrician connected in series, and when you connect in series, potential drop exists on each resistance, means that potential difference which is coming to your home, that is what, 240 volts, 220 volts, now it is getting distributed, which means every appliance is running low, and if you turn off one, everything will stop, right? And that's why we have parallel connections at our places, right? So let's summarize everything very quickly. Fine. Yes, we'll take on complex circuit diagrams. Series combination, you understand, R1, R2, R3, equivalent is NR. Summarize, parallel, you know this, R equivalent equal R by N. Fine. And it can be individually controlled. That is very important. So, I mean, I always say this, saying this again, we've got you covered. Next session is Shraddha. Yes, we'll deal with this. Come on, don't worry. We will do sessions with questions only. It's going to happen, right? Heating effective electric current, Jan 3rd, Monday. Now, I understand you will get the notification. If you have subscribed, if you have pressed the bell icon. The thing which you are here for is the quiz, mentee, alright? So, here's the drill. Today, what is different over here? What is going to be different is, this is going to be another session, right? This link is there. There's one more link in the description. Click on that link. That is for the next session. I'm also coming there. Don't worry. I understand. Today we are here. I'm just coming on that link as well. Fine. That is one thing. And then you will log on to Mentee. So guys, come on. Let's quickly drop off and quickly join that link. Because that is like a question kind of session. I want to do it separately. Fine. Come on. Let's do it. Let's go to that link which is given in your description. And I want to see all of you there, right? Don't just go here and there. Come on. Mentee number, don't worry, Trick Catalyst. Open that link. I'll again tell you this number. Don't worry. Fine. I'm coming there. Guys, be prepared. It's going to be a quiz session. Fine. Alright guys, let's drop off and meet on the next link. Come on. Bye-bye.